below, we have this linear algebra problems. Now, thing is, not anything complicated because I literally spent the entire day trying to grasp on the basics of it. Prior to that, my only experience with it was computer science. But anyhow, let's begin. First problem, we have to prove that if we were to take a system of linearly independent vectors and add lambda xj to one of the elements with index that's not j, where lambda is arbitrary, we have to prove that it's still gonna remain linearly independent. So thing is, since this is linearly independent, we were to remove this element, this would for sure be linearly independent. But we have this pesky element over here, which is problematic for us. So the only thing we really have to check is if you can linearly compose it out of the rest of the elements. So let's write down xi plus lambda xj equals the sum. Let's take variable k for the sum here, and let's take sequence alpha, for example, alpha k times xk. Cool. Now let's pull out the j out of the sum. Let's write it like that. Include j in the restriction and add it back in aj xj. So now let's take this to parts. Let's move this here. Now, thing is, according to the distributive property, we can clump in aj and negative lambda as a sum. So let's write it down. And times xj. Now we can essentially clump it back in to the sum, or to define a new sequence instead of ak. Let's go with bk. Let's define it as follows. Let's say that it's gonna be equal to ak for every k that's not equal to j. Let's say that it's gonna be equal to this part over here, aj minus lambda for k equals j. So now we can rewrite it as a sum. Bk xk and k is not equal to I. So essentially what we got is that the original statement that is composable, in other words that this system is linearly dependent, is basically equivalent to this statement. Now the thing about this statement, it says that xi can be composed out of the rest of the elements of the original sequence, given we pick a correct coefficient sequence bk. And thing is, since this original system is linearly independent, this statement cannot be true. You can compose xi out of the rest. Okay, cool. Now this, we have vectors x1, x2, x3. We have to answer whether they are linearly independent and C3. Then we have to express this triplet as linear combinations of x1, x2, and x3. So let's begin by solving a system for lambda 1 here. Next we have I and I, so plus I times the sum of lambda 2 and lambda 3 equal to 0. Now the rest, let's run it down quickly. Have lambda 2 plus lambda 3 times 2 equals 0. For the 3 we have a lambda 1 plus 1 plus I lambda 3 equals 0. Okay, now let's go one by one. First, let's express lambda 2 in terms of lambda 3. That's going to be negative 2 times lambda 3. Now we just need to repeat for the rest of the system. Lambda 1 minus lambda 3 times I equals 0. Lambda 1 equals lambda 3 times I. And now we can go here and okay, I think it matches, so I think 1 plus 2i times lambda 3 equals 0. This implies that lambda 3 is equal to 0. And since the rest of the lambdas are just factors, they are also going to be a 0. So we have proven that the linear composition of these vectors being equal to the 0 vector implies that the coefficients are all 0, therefore it's linearly independent. So now we have to deal with expressing specific vectors in terms of these vectors. So let's just write down the first system. Lambda 1 plus lambda 2 plus lambda 3 times I equals 1. Lambda 2 plus 2 lambda 3 equals 2. And lambda 1 plus 1 plus I lambda 3 is going to be equal to 3. Okay, so again, let's begin with this part because it's the easiest to express overall. So we have that lambda 2 is going to be just 2 minus 2 lambda 3. So now it's easy to work with this sum here. In the brackets, we have 2 minus lambda 3. So now we can express lambda 1, the 1 minus difference between 2 and lambda 3 times I. Now finally we can plug it into the last part of the system. So let's begin by juggling the parts of this equality for convenience sake. That this equals to 2. Now lambda 3. Okay, now let's just distribute everything. I will try to not skip steps because calculations like this one are really sensitive to errors, and if I commit one, then it's basically over for me. Plus lambda 3 times I equals 2. Now we can clump in lambda 3. 1 plus 2i equals 2 plus 2i. I hope I don't make an intermediate error because that's gonna really suck. 2 plus 2i over 1 plus 2i. Let's multiply both the denominator and the numerator by 1 minus 2i. 2 plus 2i. 1 minus 2i Now 1 squared is 1, 2i squared is -4. We have a 5 in the denominator. So now the numerator is gonna be a -4i squared is gonna be 4. We have 2 here. It's gonna be 6 for the real part, and for the imaginary, plus 2i minus 4i is gonna be -2i over 5. Okay, we have found lambda 3. Now lambda 2. Lambda 2, we have expressed as 2 minus 2 times lambda 3. So 10 minus 12 plus 4i all over 5. I think that's how it would go. Minus 2 lambda 3. Okay, it seems correct. -2 plus 4i over 5. And for lambda 1, we have expressed it somewhere. 1 minus 2 minus lambda 3 times I. God, this is gonna be annoying to deal with. Okay, let's copy paste it first. So 2 minus lambda 3. 1 minus... Okay, let's deal with this part first. Interesting thing here is actually 2 minus lambda 3. Lambda 2 is 2 minus 2 lambda 3, so we can just add lambda 3 to lambda 2. That's gonna be 4 plus 2i over 5 times I. So we have 1 minus minus 2 plus 4i over 5. And that's gonna be 10 plus 2 minus I over 5. And that in turn is gonna be 12 minus 4i over 5. Now, I will check this, but it seems too cumbersome because it's all fractions. I don't want to deal with that. Sorry. You can check it yourself. You can say that if I were correct or if I did some stupid mistake midway. Okay, so that's our system. Basically equivalent. I don't want to bother to write it down. We just need to swap the values here. Okay, so by the classic, let's begin this part because it's the easiest one to deal with. So lambda 2 is going to be equal to I minus 2 lambda 3. Now let's deal with this equation even, not just any expression. It's going to be lambda 1 plus, it's going to be I minus lambda 3 times I equals I. Now if we were to transport this to the right hand side, it's going to be I times 1 minus I plus lambda 3. Okay, so we have expressed lambda 1 in terms of lambda 3, so we can plug it in here now. So let's begin by transporting this to the right side. I think it would be handy because 1 minus 1 is going to be 0. Minus I is going to be just I, and minus lambda 3. Okay, lambda 3 plus I lambda 3 equals -1 minus I lambda 3. Now let's add the I lambda 3 to both sides. We'll have lambda 3 times 1 plus 2i equals -1. Lambda 3 equals to -1 over 1 plus 2i. Let's multiply both the numerator and the denominator by 1 minus 2i. It's going to be 5 in the numerator, 1 minus 2i in the... Okay, I said numerator, I meant denominator here, and here's the numerator. Let's bring in the minus. That's going to be -1 plus 2i over 5. Okay, now we need to calculate the rest. Express that lambda 1 is going to be equal to this monstrosity. So let's try to reduce it to something simpler. I plus 1 plus lambda 3. Let's just write it down as 5 I plus 5 over 5 plus -1 plus 2i over 5. And now we can just add it together simply. That's going to be 4 plus 7i over 5. We got our lambda 1. Now we have to find lambda 2, which is probably simpler. The 2 is going to be equal to this. It's going to be 5i plus 2 minus 4i over 5. It's going to be 2 plus I over 5. And we're done here. Now, I get that it's not even nearly the level of linear algebra you want me to tackle. Probably wanted to some linear transformation related stuff, matrices. Now, I technically knew it on a very shallow level from computer science, but I wanted to go into a little bit more rigor, especially here. Most of the video is occupied by me just finding the solutions to the systems. I'm sorry, I'm really sorry. I tried to dive into linear algebra today. I downloaded a textbook, I went through it, it had a lot of rigor, I liked it, but it was complicated to grasp, so I ended up not getting a lot of info overall, so I really couldn't do anything far more complicated because of lack of information or understanding of the topic. So I'm sorry, I hope you liked it anyways, I'm really sorry. Okay, bye, yeah.